In this video, we're going to use the TI-84 Plus or TI-83, fairly similar, to do statistical calculations on a frequency distribution. So this is my version of a TI calculator that I have on my computer. Over here on the left side, these are all the keys that you'll see on a standard TI-84. And then here in this white region, this is where everything will be outputted or inputted into the calculator. And then down below, you'll see a key press history, so that if you can't see the little cursor pushing the buttons, you'll be able to read all the buttons and be able to get the same output as I do. Now, if I make a mistake and I have to delete something, you're going to see that as well. You'll see little delete, or arrow keys, whatever it is. So just know to sort of ignore those if I make a mistake. Don't try to make the same mistake as me. So let's start off by entering data into our calculator. So the way that we enter in data is we're going to push stat, and then we're going to go over here to edit. So the number 1 is edit. You can push enter because it's highlighted, or you can also push the number 1 and it will bring you to the lists. So by default, the TI-84 has about 6 lists. They call them L1, L2, and I can scroll up through them by pushing the arrow keys. There's L2, here's L3, L4, L5, L6, and then there's some blank ones that you can name yourself. So if I go back over to my L1, whoop, overshot it a little there. There we go. Now you might find that you actually have some data already in your lists, maybe because you're borrowing the calculator or you used it for something else. I'm going to just type in some data and show you how to get rid of it. Like I'm going to type in the number 3 and then I push enter to go down to the next number, 4, 5, okay. You might also have some numbers over in a second list. This works the same way. So to get to deleting it, you can push the delete button on your calculator. So if I highlight the number 5 and then push delete, it goes away. Or maybe I want to get rid of the 3 only. I'll push delete and it will go away. Another way to get rid of all the numbers in a list is to go up to the list name and push clear. Don't push delete, push clear. Push clear and then push enter and all your data disappears. It's really easy, especially if you have a lot of data in this column. Now I said don't push delete. I'll show you what happens when you push delete. I'm going to move up. I'm going to use a different list because I want to keep my L1s and L2s. If I accidentally highlight the number and then push delete, the list actually goes away. Now, what really happened is the list is no longer showing up here. The list still exists in your calculator and it can be referenced, but it just doesn't show you there. So if that happens, email your instructor and she can help you put it back into cycle. Basically, you delete everything out and just rename everything. But let's work with L1 and L2. So back to putting in data here. That was just a little sidetrack of how to clear everything on your calculator, since I imagine many of you won't have empty lists to start with. So I had an example where there was a sample of students and we asked them how many students or how many siblings they had in their family. So some of the answers were 0 siblings. So we're going to enter in 0. And then there was 1 sibling for some students, 2, 3, 4, 5, 8 siblings for 1 student, 12 siblings, and then 15 siblings. So I'm just typing in the number and then pushing enter, and I filled in my list. Now, there were 30 students who took the sample, who were in the sample. So certainly L1 doesn't show you 30 numbers. I can tell that there's only 9 numbers in the list because I've highlighted the last number, and see that little 9 in that bottom row? That's telling me that in list 1, space number 9, I see the number 15. So in a frequency distribution, you show each unique number once, and then in the second column, you tell us how many times the number was repeating. So there were 3 students who had 0 siblings. There were 4 students who had 1 sibling. And then I'm going to continue filling in these numbers with a 7, a 6, a 4, a 3, 1, 1, and then 1. So when you're working with a distribution like this, make sure that your columns have the same length. So the 10 space is blank, the 10th space is blank. So these have the even rows or even columns. If you don't have even columns, go back, fix your data so that you do have the same columns. If you don't fix your data and you try to do calculations, you'll probably get an error. So if there's an error, go back and check your original data. That's the fastest way to start over, and then continue. Okay, so we have our data in our list. I can go back up to the top. Eventually, there we go. Oh, a little overshot that a little bit. There we go. So now we're up at the top. All right, so now let's do the calculations. The data are in. We need to compute a mean, or maybe we want a median, some other number. All of this can be done with a couple keystrokes. We're going to push the stat button. Stat's our favorite button here. And then we're going to go over to the calc menu. So push the right arrow key. So over 1. And then we're going to compute 1 variable statistics. So don't go to 2 variable statistics. We still have 1 variable because it's just how many siblings do you have. That second column doesn't mean it's a second variable. The second column is just telling us a frequency. So how many of each sibling do we have? So 1 variable statistics, you can push the number 1 or you can push enter to get into this next spot. All right, so on your input here, we need to tell the calculator what list we're going to find our data in. So the number of siblings is in L1. Now let's say that you didn't use L1. That's totally fine. You don't have to use L1 and L2. If I needed to get to a different list, I could delete whatever's there. And then if you look at your calculator and all the buttons, you can see above the number 1 how it has a little blue L1. Above the 2, there's a little L2. This is how you can reference each of the lists. So if I want to type in L1 after I cleared or deleted that other list, I would push the second button, the blue button, and then the number 1, because L1 is there attached to the 1 button. I have now put in L1. So my data was in L1, that's the list. If I go down, so down arrow to the frequency list, this is where I'm going to use L2. So that was how many times did the number repeat? That was that list. So this was an L2, I need to push second and then L2. Or the number 2. If you end up accidentally typing a letter, just delete it out and keep trying until you get the L2. Remember that the blue matches the blue button. Some calculators, older calculators, will not have this exact looking input. That's okay. We might actually see what's going to happen next. So I put in the list, I put in the frequency list, now I need to go to calculate. So down arrow to calculate. I've highlighted that word calculate and then push enter. And it blipped on the screen just ever so briefly, but let's see if I can go back up to it. Oh, nope, I don't think I can. For those of you with an older calculator, when you choose 1var stats, you have to type in yourself, the 1var stats shows up, and then you have to type in L1, L2. So that's a little different with the older calculators. The L1, L2 means that your data's in L1, and then, oh, by the way, your frequencies are in L2. And once you push enter, and what automatically happened here is that you get the calculations for 1var stats. So let's look at all of this output here. So the first row says X bar, that is your average. Now, if it's a sample, it's of a population, it doesn't matter. The average is still the same. So the average number of siblings is 3.4. The second column here, or the second row, is the sum of the X's. So how many siblings total were in our sample? There were 102 siblings. The third line down doesn't really have much meaning. It's part of a calculation. You might see it if you're working by hand, but you can kind of ignore this second and third row. This is the sum of the squared x's. So take each x value, square it, and then add them all together and you get 658. So there's 658 square siblings in our sample. Again, not much meaning. Now the fourth row, this is interesting. SX stands for standard deviation of the x values. So the standard deviation for our sample is 3.28 siblings. Because we knew we started with a sample, this is the standard deviation we want to focus on, SX. The fifth line down, if you know you have a population, and you'd have to read that in the problem setup. If you have a population, you would look at this row. So you're either going to look at the fourth row or the fifth row to get an answer for what's the standard deviation. If you know you have a sample, look at the fourth row. If you know you have a population, you look at the fifth row. And then n equals 30, so there's our sample size. Now there's more output here, and I'm going to push the down arrow to get to it. So below, and I could tell that there was more because this little down arrow here on the left. The minimum value is 0, so the smallest number of siblings is 0, and keep pushing down. The first quartile is 2 siblings. That has been calculated for us. The median is 3 siblings. The third quartile is 4 siblings, and the max value is 15 siblings. So in just this calculation here, I'm able to look at the sample mean, the sample median. I'll be able to calculate the range, 15 minus 0, to get 15. I can calculate the IQR, 4 minus 2, so now I have 2. And I also got the sample standard deviation, all with just this calculation. So there you go. That is how you calculate one variable statistics or summary statistics for data that came from a frequency distribution on the TI-84 calculator.